The contamination caused by acid mine drainage is a persistent problem. However, limestone beds offer a natural and cost-effective solution. They help raise pH levels, add alkalinity, and remove harmful metals. Over time, though, these beds can get clogged and coated with solids, which reduces their effectiveness. Replacing the aggregate is often expensive and wasteful. But what if there was a better way? Join us as we explore 4 innovative methods to clean and restore limestone beds. This can save time, money, and help the environment. Removing the solids from the limestone is easy. The challenge is what you do with them. No matter which method you choose, a good supply of clean water and a settling pond to capture solids are critical for success. The method of limestone cleaning that just about everyone tries first is to spray water on the stone while mixing it with an excavator. The bed is drained and a hole is excavated to create space for placement of clean stone. Water is then sprayed on the dirty stone as it is handled. The clean stone is then placed in the hole excavated at the beginning. Rinse water flows out of the limestone bed's effluent pipes. Fine solids can flow out with the rinsed water, while coarser solids stay in the bed. Digging a trench to the effluent pipe can help move fine solids out. However, coarse solids often settle at the bottom of the limestone bed. Since the solids rinse off easily, using a higher volume of water is better than high pressure for carrying the solids away. The cleaning rate typically ranges from 75 to 150 tons per hour. Still, the use of this method is highly variable depending on how diligently the operators perform the work. This method's efficiency requires good management of the aggregate as it is cleaned. While this method allows some removal of solids, most of them settle to the bottom of the bed. Another effective cleaning process is the dozer method, which uses bulldozers to push the fouled stone through standing water. With the bed completely full of water, the operator creates an alley of standing water to push the stone through. The alley can be widened by cutting each edge back so the stone falls into the water. During cleaning, direct as much water flow as possible to the limestone bed. As the cleaning continues, gradually lower the water level to match the height of the unclean stone. This ensures a steady discharge of water throughout the process. Even with a continuous discharge of turbid water, coarse solids will accumulate on the bottom of the bed and form a hardened layer of limestone chips and sand. If repeated cleanings occur, this layer of solids will accumulate to a thickness that warrants removal and disposal. The thickness of this layer will vary from system to system. The advantage of this method is its simplicity and the availability of equipment and skilled operators. The cleaning rate depends on the size of the equipment and the distance the stone has to be pushed, but it typically averages 100 to 150 tons per hour. The screening bucket method uses an excavator-mounted screening unit along with a wash basin. There are 2 main types of excavator-mounted screening units available on the market, which differ based on the orientation of the rotation axis in relation to the machine's boom. The perpendicular axis model is known as a flip screen and is manufactured by a company of the same name. The screen unit can be submerged in water and rotated to help dislodge and remove solids from the stone. A stone boat or roll-off container can be used as a wash basin, with fresh water pumped in and turbid water pumped out to the settling pond. The excavator scoops up a load of stone and rotates the screen unit 3 to 6 times, depending on how dirty the stone is, before placing it in the clean pile. This method captures and removes all the solids from the bed, though the stone can also be cleaned directly in the bed instead of in a roll-off container. Good planning is required to ensure that clean and dirty stones remain separate. This method is highly effective, but limited by the availability of specialized equipment. During our trials with the flip screen, we measured a cleaning rate of approximately 70 tons per hour. Larger models can clean stone faster, but require a larger and more expensive excavator to operate. The trommel screen is the most complex method for stone cleaning. This rotating cylindrical screen tumbles the stones, similar to a flip screen, but it is a large stationary unit that is fed by an excavator. Fouled stone is loaded into a hopper using an excavator. It then falls into a rotating drum screen made of a 1/4-inch thick punch plate. As the stone is loaded into the hopper, water is sprayed over it, allowing it to tumble within the screen. Solids and water that pass through the screen are collected in a pan beneath the screen and are pumped to a settling pond. Clean stone is discharged via a conveyor to a stockpile. The process generates coarse solids and fine gravel that are difficult to remove from the solids collection pan and can accumulate in the disposal pond. This method could be improved by making the screen openings smaller and closing the gaps where limestone chips currently fall into the pan. This will decrease the amount of coarse solids produced. The trommel screen method is already quite effective, with a throughput of 80 to 100 tons per hour. While it will continue to improve over time, this method shows great potential for achieving even faster cleaning rates and possibly lowering costs. The rinse and mix method and the dozer method use simple techniques with common equipment. However, they don't effectively remove solids from the bed. Over time, a more thorough maintenance effort is needed. On the other hand, the screening bucket and trommel methods do a great job of removing solids, but require specialized equipment. Each method we've highlighted shows that we can sustainably treat acid mine drainage. By restoring limestone instead of replacing it, we can maximize efficiency, cut costs, and protect our ecosystems. Together, we can transform fouled limestone into a foundation for cleaner water and a healthier future.